here is the second rule for undetermined coefficients. And for this, let's try to find a general solution of y double prime minus 2y prime minus 3y equals 9t squared. So if you remember the fact that I talked about in previous videos, to find a general solution, you first find a homogeneous solution and then add a particular solution. So let's find a homogeneous solution. So in this case, we need to solve y double prime minus 2y prime minus 3y equals 0. In this case, the auxiliary equation is r squared minus 2r minus 3 equals 0. And if you want, you can factor this out and you get r equals 3 or r equals minus 1. So in this case, the homogeneous solution is ae to the 3t plus be to the minus t. That's it. And now let's find a particular solution. Step 2. Particular solution. And in this case, let's look at the right-hand side. And notice the right-hand side is a polynomial, right? A quadratic function can be linear, can be cubic. And the idea is whenever you have a polynomial, you just guess yp to be a polynomial of the same degree. So rule 2, if the right-hand side is a polynomial, you just guess yp to be a polynomial of the same degree. And it's much easier explained with examples. So for instance, if the right-hand side is 3t plus 2, that has degree 1, then you guess the most general polynomial of the same degree, which is at plus b. If the right-hand side is 2t squared minus 3t plus 4, which has degree 2, then you guess yp to be at squared plus bt plus c. So here, yp is 9t squared, which is, or here the right-hand side, which has, again, degree 2. So we guess, in this case, anything of degree 2. So careful, not just at squared, but the whole thing. So at squared plus bt plus c. So again, look at the degree of the polynomial. Here it's degree 2, and guess the most general polynomial of this degree. And now we want to plug in. So y double prime minus 2y prime minus 3y is 9t squared. So at squared plus bt plus c double prime minus 2 at squared plus bt plus c minus 3 at squared plus bt plus c equals 9t squared. Now it looks like a nightmare, but if you differentiate this once, you get 2at plus b. If you do it twice, you get 2a. It's a derivative here. And then minus 2 times 2at plus b. And then minus 3 at squared plus bt plus c equals 9t squared. So 2a minus 4at minus 2b, and then minus 3at squared minus 3bt. I know it's a nightmare, but minus 3c equals 9t squared. And you see on the right-hand side, you have a quadratic thing. It would be nice if you can write the left-hand side as a quadratic thing, but we can do that. Let's just gather the coefficients. So 4 minus 3at squared minus 4a and then minus 3bt. So we just looked at terms of degree 1, and then let's look at terms of degree 0. So I think we have 2a minus 2b minus 3c plus 2a minus 2b minus 3c. And that's really 9t squared, but it's 9t squared plus 0t plus 0. And then all we have to do is to compare the coefficients. So minus 3a is 9, minus 4a minus 3b is 0, and then maybe in green, 2a minus 2b minus 3c is 0. Okay, so let's do that. Minus 3a is 9, minus 4a minus 3b is 0, and then 2a minus 2b minus 3c is 0. Now it looks horrible, but you can solve it one step at a time. So a would be minus 3, and then b, I think it's minus 4/3 a. And so minus 4/3 times minus 3. So b would be 4. And then here what we have is 2 times minus 3 minus 2 times 4 minus 3c is 0. So I think this becomes minus 6 minus 8. So minus 14 minus 3c is 0. And so c is minus 14/3. And so what is our particular solution? Yp, again, is at squared plus bt plus c. And that becomes minus 3t squared plus 4t minus 14/3. We're not quite done because we found a particular solution. Now we just need to find a general solution. So y is y0 plus yp, which is ae to the 3t plus b e to the minus t, and then minus 3t squared plus 4t minus 14/3. Next up, rule 3.